The digital revolution has fundamentally reshaped our world. It influences how we communicate, how we work, and how we understand the world around us. At the heart of this revolution lies a history of innovation and ingenuity, a relentless pursuit of a future driven by technology. This future, our present, is intricately intertwined with the history of the computer. To truly grasp the significance of the digital revolution, we must first journey back to its roots, to the very first computer. From simple calculators to complex algorithms, the desire to compute, to process information, is woven into the fabric of human history. But it was the invention of the computer that truly ignited the digital revolution. This invention, however, was not a singular event, but rather a culmination of ideas, experimentation, and breakthroughs that spanned decades. It was a journey fueled by the dreams of visionaries and the tireless efforts of countless individuals who dared to imagine a world transformed by computing. Long before the silicon chips and microprocessors that define modern computing, the concept of calculation was deeply intertwined with human activity. Ancient civilizations developed sophisticated systems for counting, tracking time, and studying the stars. These early tools, from the abacus to the astrolabe, represented humanity's first steps towards automating complex calculations. The desire to simplify and accelerate calculations drove further innovation. In the 17th century, mathematicians like John Napier and William Oughtred developed logarithms and slide rules, tools that greatly simplified complex mathematical operations. These inventions paved the way for a new era of scientific discovery, enabling scientists and engineers to tackle increasingly challenging problems. The 18th and 19th centuries witnessed the rise of mechanical calculators, intricate machines designed to automate arithmetic operations. Blaise Pascal, Gottfried Wilhelm Leibniz, and others developed calculators capable of addition, subtraction, multiplication, and even in some cases, division. These mechanical marvels laid the groundwork for the development of more complex computing devices. It was against this backdrop of increasing mechanization and a growing fascination with automation that the seeds of the first computer were sown. The stage was set for a revolution, a paradigm shift in how we processed information and interacted with the world around us. The dawn of the 19th century saw the rise of Charles Babbage, a brilliant British mathematician and inventor whose ideas would lay the foundation for the computer age. Frustrated by the limitations and inaccuracies of existing mechanical calculators, Babbage envisioned a machine that could perform complex calculations with speed and precision. This vision, fueled by a deep understanding of mathematics and a passion for innovation, would lead him on a lifelong quest to create a machine unlike any other. Babbage's journey began with the difference engine, a machine designed to automate the creation of mathematical tables. These tables, crucial for navigation, engineering, and scientific research, were often riddled with errors due to the tedious and error-prone nature of manual calculation. Babbage's difference engine aimed to eliminate these errors by automating the process, ensuring the accuracy and reliability of these essential tables. The analytical engine, as envisioned by Babbage, was a marvel of mechanical engineering. It consisted of thousands of precisely crafted gears and levers performing complex calculations. At its heart was the mill, analogous to the CPU in modern computers. Another crucial component was the store, a memory unit holding numbers and intermediate results. Babbage devised a system of punch cards to control the analytical engine's operations. Section 3. Ada Lovelace, the Enchantress of Numbers. Charles Babbage's analytical engine found a brilliant collaborator in Ada Lovelace, the first computer programmer. Lovelace, daughter of poet Lord Byron, had a keen intellect and love for mathematics. She met Babbage in 1833 and was captivated by his work. Lovelace saw its potential beyond calculations, envisioning it manipulating symbols and information. Section 1. The Colossus of Bletchley Park. As the world plunged into World War II, computing took a sharp turn. The war's demand for intelligence gathering fueled an unprecedented acceleration in computing technology. At the heart of this innovation was Bletchley Park, the epicenter of Allied code-breaking efforts. Here, Alan Turing and his team deciphered the encrypted messages of the Axis powers. Under Tommy Flowers, they built Colossus, changing the course of computing history. The Enigma machine, a marvel of German engineering, was the cornerstone of their secure communication network. It scrambled plain text messages into a seemingly random string of letters, rendering them incomprehensible without the correct key. The code breakers at Bletchley Park needed a machine to mimic the Enigma's internal workings electronically. Colossus was designed to exploit a weakness in the Enigma's encryption process. By breaking the Enigma code, the Allies gained crucial insights, shortening the war and saving countless lives. While Colossus was breaking codes in the shadows of Bletchley Park across the Atlantic, another computing giant was taking shape. The Electronic Numerical Integrator and Computer, or ENIAC, was born out of a collaboration between the United States Army and the University of Pennsylvania. ENIAC was a behemoth of a machine, occupying over 1,800 square feet and weighing 30 tons. Unlike Colossus, ENIAC was a general-purpose computer, capable of a wide range of calculations. This flexibility made ENIAC a groundbreaking achievement, paving the way for modern computing. The legacy of wartime innovation in computing extended far beyond the immediate impact of Colossus and ENIAC. The technologies developed during the war, from the use of vacuum tubes to the concept of programmable machines, laid the foundation for the rapid advancements in computing that would follow in the post-war era. The war also fostered a new generation of scientists, engineers, and mathematicians who had been immersed in the world of electronic computing. These individuals, inspired by the wartime achievements of Colossus and ENIAC, would go on to make groundbreaking contributions to the development of the first commercial computers and the rise of the computer industry. The wartime experience also highlighted the strategic importance of computing power. Governments and militaries around the world recognized the critical role that computers could play in national security, scientific research, and economic development. This recognition led to increased funding and support for computing research, fueling further innovation and accelerating the pace of progress. The journey from Babbage's mechanical dreams to the electronic reality of Colossus and ENIAC was a testament to human ingenuity and the relentless pursuit of technological advancement. The war, for all its horrors, had inadvertently ignited a technological revolution that would reshape the world in the decades to come. The post-war era witnessed a seismic shift in the technological landscape. Behemoth computers emerged from war, entering public consciousness, heralding the information age. This period saw the birth of commercial computing, altering human-machine relationships. The transition faced challenges, with early computers, like ENIAC, being impractical for widespread use. The answer lay in developing compact, affordable, user-friendly computers. Pioneers envisioned computers as indispensable tools, transforming industries and revolutionizing work and life. UNIVAC, why? Predicting the Future, developed by J. Presper, Eckert and John Mauchly. UNIVAC's AI was a cultural phenomenon. It was smaller, faster and more reliable, paving the way for business adoption. In 1952, UNIVAC predicted Eisenhower's landslide victory, stunning the nation. Section 3, Beyond Calculations, Expanding Horizons. The success of UNIVAC ignited a flurry of innovation in the nascent computer industry. New companies emerged, eager to capitalize on the growing demand for business-oriented computing solutions. The focus shifted from purely numerical calculations to broader applications, such as data processing, record keeping, and early forms of automation. One of the key drivers of this expansion was the development of more sophisticated programming languages. Early computers were notoriously difficult to program, requiring specialized knowledge and tedious manual input. The introduction of languages like Fortran and COBOL made it easier for programmers to write instructions for computers, opening up new possibilities for software development. Businesses began to recognize the transformative potential of computers. Banks, insurance companies, and other large organizations invested heavily in computer systems to automate tasks and improve efficiency. The computer revolution was well underway, transforming industries and reshaping the business landscape. Today. As the 1970s dawned, a new generation of entrepreneurs and hobbyists began to emerge. Mainframe computers were powerful but expensive, complex, and physically imposing. These pioneers envisioned a future where computers would become commonplace tools for individuals. This movement, initially dismissed by many, was fueled by a spirit of DIY ingenuity. Early adopters embraced the challenge of building and programming their own computers. The advent of the microprocessor dramatically reduced the size and cost of building a computer. This technological breakthrough made it feasible for individuals and small companies to enter the market. The stage was set for a paradigm shift in computing, democratizing access to this powerful technology. In January 1975, a magazine cover graced the front of Popular Electronics, altering the course of computing history. The cover featured the Altair 8800, a boxy contraption with a front panel adorned with switches and LEDs. This machine, offered as a kit for hobbyists by MITS, would ignite the personal computer revolution. The Altair 8800, named after a fictional destination in Star Trek, was far from user-friendly. It lacked a keyboard, monitor, and permanent storage device. Users had to manually enter programs using switches, and output was viewed through blinking lights. Despite its limitations, the Altair 8800 offered individuals an unprecedented opportunity to own and experiment with a computer. The response was phenomenal, with MITS flooded with orders. Enthusiasts embraced the challenge of assembling and programming the Altair 8800. They formed clubs and shared their knowledge with others. The Altair 8800 proved there was a market for affordable, accessible, and empowering personal computers. While the Altair 8800 ignited the personal computer revolution, it was Apple Computer that brought personal computing to the masses. Steve Jobs and Steve Wozniak founded Apple in 1976, aiming to create elegant, user-friendly computers. Wozniak's technical brilliance led to the creation of the Apple I, a fully assembled computer. The Apple I demonstrated the potential for a powerful and accessible computer. However, it was the Apple II, introduced in 1977, that revolutionized the industry. The Apple II featured a sleek design, built-in keyboard and color graphics. It was a computer for everyone, used for education, entertainment, and personal productivity. The Apple II's success paved the way for a new era of personal computing. Computers became an integral part of homes, schools, and businesses worldwide. The hardware innovations of the early personal computer era were linked to the emergence of a vibrant software ecosystem. Early PCs like the Altair 8800 and Apple II were blank slates, their potential unlocked by software. A new breed of software developers emerged, eager to create applications that made these machines indispensable. Operating systems like CP, M, and MS-DOS provided a standardized platform for software development. This standardization fostered the growth of the PC software market. Word processing software and spreadsheet programs revolutionized the way people worked. The PC software market matured, driving the adoption of personal computers. Businesses and individuals sought software solutions to improve productivity and creativity. The rise of software was a driving force in the personal computer revolution. By the early 1980s, the personal computer revolution was in full swing. Computers were becoming increasingly commonplace in homes, schools, and small businesses. The democratization of computing power was driven by decreasing hardware costs and growing software availability. The impact of the personal computer revolution was profound and far-reaching. It transformed the way people worked, communicated, and accessed information. Personal productivity software led to significant gains in efficiency. Connecting PCs to networks and the internet opened up new possibilities for communication and collaboration. The personal computer revolution was a cultural phenomenon that empowered individuals and fostered creativity. It was a testament to the power of human ingenuity and the belief that technology can improve lives. By the late 1970s, the personal computer market was a chaotic but exciting frontier. Apple had established a strong foothold, but no single company dominated the market. This changed with the entry of IBM. IBM initially viewed the personal computer market with skepticism. However, the success of companies like Apple convinced IBM to enter the market. In 1980, IBM assembled a team to create an IBM personal computer. This team, Project Chess, was given autonomy and a tight deadline. Breaking with tradition, Project Chess used off-the-shelf components. They chose Microsoft to provide the operating system. This decision paved the way for Microsoft's dominance in the PC operating system market. The IBM PC, unveiled in 1981, was a capable machine with an open architecture. This open architecture allowed third-party companies to develop compatible products. The IBM PC's success reshaped the personal computer industry. Section 2, the Open Architecture Advantage. On August 12, 1981, IBM unveiled the IBM Personal Computer, or IBM PC. The true genius of the IBM PC lay in its open architecture. Previous personal computers were self-contained systems with tightly integrated hardware and software. IBM opted for an open architecture, publishing technical specifications openly. This allowed other companies to develop and sell compatible hardware and software. The open architecture approach was a gamble for IBM. It meant giving up some control over the IBM PC platform. However, the potential rewards outweighed the risks. The open architecture fostered a vibrant ecosystem of third-party development. This made the IBM PC more appealing to consumers and businesses. The IBM PC's open architecture created a virtuous cycle of innovation and competition. The personal computer industry experienced unprecedented growth and innovation. Section 3. A standard is born. The open architecture of the IBM PC led to the creation of a de facto standard in the personal computer industry. Companies creating personal computers could focus on compatibility with the IBM PC standard. This standardization had a snowball effect. As more companies adopted the IBM PC architecture, the availability of compatible hardware and software exploded. Consumers benefited from lower prices and a wider selection of products. Businesses embraced the IBM PC platform, confident in finding software and support. The IBM PC's open architecture created a virtuous cycle of innovation and competition. The personal computer industry experienced unprecedented growth and innovation. The IBM PC standard transformed the personal computer industry. Section 1, from humble beginnings to ubiquitous computing. From Babbage's analytical engine to modern interconnected devices, the journey of computing has been extraordinary. Computers have evolved from room-sized behemoths to ubiquitous tools that empower individuals and fuel innovation. The story of the first computer is a testament to human ingenuity and our relentless pursuit of knowledge. Pioneers like Babbage, Lovelace, and the minds behind ENIAC laid the foundation for the digital age. Their insights and innovations have fundamentally altered the way we communicate, work, and learn. The computer has become an indispensable part of our daily lives. The software that powers these machines has become an integral part of our digital lives. The internet has broken down geographical barriers and facilitated global communication. The journey of computing is a testament to the power of human ingenuity and the belief that technology can improve lives. The unfolding future of computing. As we stand at the cusp of a new era in computing, the pace of innovation shows no signs of slowing down. Quantum computing and AI are revolutionizing fields like medicine and finance. The convergence of computing with biotechnology and robotics is blurring the lines between the physical and digital worlds. Imagine a future where computers are integral parts of our environment. This future, once science fiction, is rapidly becoming reality. The journey of computing is a testament to human curiosity and the power of technology. The future of computing is shaped by our choices and innovation.